We'll now discuss the third approach for handling selection, which is switch structures. A switch structure is very different from an if statement or an if-else statement because we don't need to evaluate any logical expressions. So we don't have to worry about comparing two values if one is greater than the other, or if they're equal to each other, or if they're less than, and so forth. We don't do any of that with switches. Instead, we're given a list of multiple alternatives based on some specific value. So we're given a variable, it has some value, and we have these different cases that we can do depending on what that value is. So let's take a look at the format of a switch structure. So we start with our opening statement. So we have the keyword switch, and then we have some expression in the parentheses. Now this expression is going to evaluate to a single value, whether it's an integer or a character, and we'll go over some rules with what's supposed to go in this expression. And what we put inside of here are what we call cases. So the way this works is we put the word case, and then value 1 is going to be a possible value of our expression. So this is a case that our expression can actually evaluate to. And then we end it with a colon. And what comes after that are all the statements that would happen under this specific case. And then for each case that we have, we always end it with a break statement. So remember, what this means is that we're going to get out of this. I don't think we've talked about the break just yet, but what this means is once we've executed the break statement, I get out of this switch statement, which means I go from here all the way out of the switch statement. So we're pretty much done at that point. Now, this gives me one possible case for the value of our expression, but we can have as many cases as we want. So we can have another case, which gives me a different value, so whatever value 2 is, and I can execute certain statements based on it. And then I have my break, which means that I'm done with that case and I get out of the entire switch expression. So we can put as many of these as we want, and finally we get to like some final case. So here I'm just using value n as a term, but we just have however many cases we want. There's no limit. The main thing is that each case corresponds to a specific value that our expression can be. Now, the last thing that all switch statements need is a default case. This is simply means that we evaluate our expression, we've looked at every single case, and none of the values match what our expression actually evaluated to. So you can think of this default as that final else or that other category. So these statements would only happen if none of the other cases above happen. And notice there's no break statement afterwards, because once we're at the very bottom, we just simply leave the switch statement. Now, there are a couple things we need to mention about the switch expression. First of all, the expression in the switch, what goes in the parentheses, this part right here, this has to be either an int or a character. Some versions of Java, I think, may allow strings, but depending on what version of Java, that may or may not work. So right now, to play it safe, your expression can only evaluate to either an integer or a character. But I think some later versions of Java do allow strings, so I cannot confirm that on the version of Java that you're using. And the value that this expression evaluates to determines which case that we pick. Each case contains a possible value that the expression could be, because as we said, the whole purpose of this is our expression can evaluate to one of several possible values. So each case is going to handle one of those specific values. That means each case value must be unique. We can't have duplicate case values. And each case can have one or more statements to run. So you can have just one line of code in there. You can have as many lines of code that you want. You just have to make sure that you end it with that break statement. So like I said, the purpose of the break statement is it lets Java know that we're done with the switch statement. We can just simply get out of it. We would recommend putting the break statement after every case, but there are some situations, and we're going to see an example of this in a little bit, where maybe we have several cases and they're all going to do the same thing. So we're going to see a neat little trick that will allow us to write the code once, but for any of those cases, we'll run that set of code. It's a pretty neat trick, but most cases we're going to end each case with a break statement. Because if we do not include the break, then we could execute statements for multiple cases. Sometimes we want this to happen Other times we may not. So it's just one of those things you have to be really careful with how you set up your switch statement. And then, as I said before, the default case simply handles all the other cases that don't match any of the other case values. So what happens when we evaluate this is we get our value and we look at every single case, and we're simply comparing if our value is equal to that case value. And if any of them do equal each other, then we'll run that case. But if none of them match, then we're going to go to the default option, and then we'll execute the lines of code that we have there. Now, there are 3 rules when using switches, and we've kind of gone over these already, but we're just going to make sure we're very clear with the rules. So the first rule is that when we get our expression value, whenever the value of that matches one of our case values, we're going to run the statements underneath that case. And we keep running all the lines until one or two things happen. Either we get a break statement or we're at the end of the switch. The second rule is if our expression value does not match any of our case values, then we're going to run the statement in our default case. We have to, so we're going to always go to that last resort if none of them match. And our third rule is that the break statement causes an immediate exit from the switch structure. So as soon as we hit that break statement, we are done executing any lines inside the switch structure. So here's an example of some code where we're printing grades. Now I've split the code into multiple columns just so we can see the entire thing, otherwise it'd be way too small to read. But we have some variable score and we're going to divide it by 10. So that's going to give me the tens digit of our score. And based on what that tens digit is, I can print out a letter grade, or at least assign a letter to our variable grade. So what does this first part over here mean? So if case is 0, so that means that our score was in the ones digit, 0 through 9. Well, we're just going to keep going all the way down until we get to this line over here. But this is also true if our case is 1, 2, 3, 4, or 5. So this is a case, I shouldn't say case, but this is a situation where we don't include any statements or break statements for specific cases. So this is saying if we get a 0, we go all the way down to the first line of code we get. The same thing is true for 1, 2, 3, or 4, or 5. And we assign F to the variable grade. And this makes sense, right? Because if you score anything between a 0 and a 59, well, if you take that value and divide it by 10, you're going to get 0, 1, 2, 3, or 5. So you should run these lines of code. So we set grade to F, and then we execute the break statement, which means that we don't run any more lines in our switch structure. Now, if case is 6, that means our score was between 60 and 69. Then we assign our grade variable the letter D, and then we do our break statement. And then we do the same thing for the letter C, B, and A. So if it's 7, then we assign C. If it's 8, then we assign B. And then for 9 and 10, we do the same thing here. So if it's 9, well, we're going to go down to this line of code here that says assign the letter A to grade. And if it's 10, which means we had 100, because 100 divided by 10 is 10, then we would assign the letter A to grade as well, and then we'd break. If we have some other number in there, so like maybe 11, maybe we can't have like 110% or a negative number, then we have our default case, which is print something that says invalid test score. Now the thing about switches is this is just one way we can handle selection, because we can take a switch statement and rewrite it as an if-else statement, because we can say in our previous example, if score divided by 10 equals 0, then print or set the letter F to set grade to F. If score divided by 10 equals 1, do something else. If score divided by 10 equals 2, and so forth. So we can rewrite a switch structure as an if-else statement. So the question is, when should we use a switch and when should we use an if-else statement? So we'll use a switch if the value of our expression is an integer or a character and we have a finite number of cases. It just allows us to simplify our code a little bit if we have those two scenarios. So when should we use an if-else statement instead of a switch? Well, if we're not going to check for equality, then we can't use a switch structure. Switch structures only work if we're checking for equality. So if we're checking if a value is less than something else, then your only option is use an if statement or an if-else statement. And then if we need to check a range of values, and not just some finite range, but if the range is infinite and we cannot reduce it down to a finite set, then we cannot use a switch. If-else statement is our only option, because remember, with a switch statement, we have a finite number of cases. So we would use an if-else statement if the number of cases is infinite.